be moving fairly quick. However, I'm counting on y'all to ask a question when you have one. I just want to make sure, that we get through the thing. I don't think we'll have too much trouble getting through it, but I'll be kind of rolling along. But make sure you ask questions if you have them, because I'm telling y'all, this practice test is very similar to the test. And so, memorizing each of these exact problems won't help you because the numbers have been changed a little bit. But like maybe the first problem, instead of 8x minus 5 equals 27, maybe it'll be, 3x minus 8 equals 32 or something. But other than changing some of the numbers, pretty much the same thing. So, okay, first problem, pretty simple, right? We just need to get x by itself. So 5 is subtracted. We're going to add 5 on each side. And when I do that, I now have 8x equals, what, 32?
Yes.
And of course, I just need to now, since 8's multiplied times x, I just need to divide each side by 8. 32 divided by 8 is 4, and that's my solution. Everybody good there? Moving on. Problem 2. Problem 2 is, it looks more complicated. That's because we need to simplify this expression on the left and simplify the expression on the right first before we start moving things from one side of the equation to the other. So here on the left, I need to distribute this 2, except make sure you see it's not 2 that I'm distributing, is it? It's negative 2. So you got to be careful about that. Make sure you don't start by doing 3 minus 2 equals 1, because that's an order of operations error, right? I would need to multiply, in other words, distribute this negative 2 first. So I've got the 3 here. Negative 2 times 2x is negative 4x. And negative 2 times positive 5 is negative 10. So we got 3 minus 4x minus 10. Everybody good there? Over on the right-hand side, I need to distribute this 2. 2 times x is just 2x. And this is positive 2 times negative 2, which is negative 4. And don't forget, we got the plus 3 out here. Now, my advice is, at this point, you still don't want to start moving things from one side of the equation to the other, because I want to go ahead and combine any like terms. And I've got constant terms that I can combine on both sides of the equation, right? So on the left side, I've got this x term, negative 4x, but I can also say that 3 minus 10 is negative 7. I wrote negative 4x minus 7. If you write negative 7 minus 4x, there's nothing wrong with that either. I just tend to put variable terms before constant terms. On the right side, I've got 2x. But I can combine negative 4 plus 3 to get negative 1. So 2x minus 1 on the right side. Everybody good there? Now I need to get all my variable terms on one side. And I can move, it doesn't matter which side I move it to. I'm just going to add 4x to each side. You could have subtracted 2x on each side. I just, I'm kind of in the habit of making my variable terms positive wherever I can. So that gives me negative 7 equals 2x plus 4x is 6x minus 1. And so now I need to, since my variable term is all on the right-hand side, I need to move my constant term to the left side. So does everybody agree that I need to add 1 on each side of the equation?
It doesn't matter if you added the 7 first, right, or the 1.
If you, we'll talk about that in a minute. Let me finish, and then I'll try to speak to that. So negative 7 plus 1 is negative 6, and that's equal to 6x, right? And of course, we just need to divide each side by 6. And so we get x by itself on one side, and on the other side, remember to watch your signs. Negative 6 divided by positive 6 is negative 1. Paris and Silver Springs, the question I had here is, when I got to this point, could I have added 7 to both sides? I could, but it adds one extra step to the problem. Like there's nothing particularly wrong with doing that. But if you do, my thought is always, if my variable term is on one side of the equation only, I'm always going to move my constant term to whatever side is opposite the variable term. If you add 7 to each side, you're going to get 0, right, equals 6x plus 6. But now wouldn't you have to either subtract 6x or subtract 6? And you just have to move, you've just moved this 7 to the right side, but then you got to move all that constant right back to the left side, which gets you right here, right?
So start with your constant, whatever.
Yeah, it doesn't matter which side you move things to, but you just got to always remember that your goal is to get x by itself on one side. So you're always thinking about what's going to get me there with the least amount of fuss. And if you do this, like see from here, from this point, I added 1, then I divided by 6 and I was done. That's 2 steps. If I did this, then now I've got to, I don't know, do we want to subtract 6, which would get me back here, or I could subtract negative 6x. Either way, it doesn't matter. I would get, if I did that, I would have negative 6x equals 6, but that's 2 steps. I added 7, I subtracted 6x. Now I've got to make a third step to divide each side by negative 6 to get finally x equal negative 1. So just to me, once my variable term's on one side, doesn't matter what side it's on, I'm going to put the constant term on the other side, right? It saves me 1 step in the sense of time. Everybody good there? Problem 3. It's fraction time. So this is an equation that involves fractions. It's not a rational equation because we don't have any x's on bottom, right? This is the one where we have to figure out what the least common denominator is and multiply every term on both sides times that LCD. Does everybody see that 6 is the least common denominator? We got to have a factor of 2. We got to have a factor of 3. 6 is literally 2 times 3, so that's exactly the factors we already know we got to have. 6 is the least common denominator. Then I'm going to distribute. I'm going to multiply 6 times each side of the equation. And it's super quick and easy on the right side because the 6 on top and bottom cancel. Everybody see? 6 goes into 6 one time, 6 goes into 6 one time. This is literally just 1 times 5x, which is 5x. So got rid of the fraction there. It was real simple. Now over here, you've got to distribute. So you first got to do 6 times 3x over 2. Once we've done that, we've got to do 6 times negative 1 over 3. Everybody see? So when I do 6 times 3x over 2, y'all should see that I can cancel a 2 here, right? Everybody with me? It's a common factor on top and bottom. 2 goes into 2 one time. 2 goes into 6 3 times. Now, I'm going to cross through that 6 and put a 3 here. And that gives me 3 times 3x, which is 9x. Everybody see that? But here's what you have to remember. It doesn't matter that I've got a 3 up here now because I canceled a 2. Canceling the 2 was part of what happened when I multiplied 6 times 3x over 2. Do y'all see that I still have to multiply all of that number 6 times negative 1 over 3? So this 3 is just here because that's a sort of a byproduct of what happened when I multiplied 6 times this first term. And so then I get 3 times 3x is 9x. But I still have to multiply 6 times the next term, right? Everybody see what I'm saying? And when I do that, I can cancel a 3. 3 goes into 3 one time, and then up here where I have the 6, 3 goes into 6 2 times. So what I actually wind up doing there is 2 times negative 1, which is negative 2. Everybody see that?
Can I ask a question just really quick? I mean, I think
Yes.
this was like I don't want to get into a big battle. I just want to make sure that my arithmetic is also correct. I can also do 6 times 3 divided by 2 and 6 times -1 divided by 3, right?
Yes.
Okay,
Well, when
thank
you
you.
do you get this exact same thing?
Yes.
So yeah, I mean, yes,
And
you can.
okay,
And
okay,
if you do it, you should see that when you simplify it, you get the same thing.
okay. I just wanted
Okay,
to
so
make
everybody,
sure that
yeah, no,
I could.
that's perfectly fine. Is everybody good to hear? Okay, so this is that same kind of deal. Like, should I add 2 to each side or what should I do? I'm just going to say, since my constant term is all on the left, I'm just going to subtract 9x on both sides to get my variable term on the side opposite the constant term. You could add 2 to each side, then you'd subtract 5x and so on. It works fine. But if I subtract 9x on each side, I'm going to get -2 equals 5x minus 9x is -4x, right? And so I would need to divide each side by -4. And of course, that gives me x by itself on one side, which is what I was trying for. Does everybody see on the other side, first of all, negative divided by negative is going to be positive. And of course, we would want to simplify that fraction and say that 2 goes into 2 one time and 2 goes into 4 two times. So I actually get x equal positive 1/2. Everybody good there?
So on the test, if we write x equals 0.5, are you going to cut it wrong?
No, but I'll hate it.
Okay.
If you do the problem on the test and your answer is x equal, if my answer would be x equal 1/3, what would be your answer?
X equals 1/3.
Well, then why wouldn't you say x equal 1/2 here?
It was just a question. I don't want to write 0.5 and get it wrong. It's like my calculator told me 0.5.
Okay, what does your calculator tell you? What if we did this? What if we got, what does your calculator tell you there? I bet it doesn't say 1/3. I know what it will say, but it won't be 1/3. It'll be 0.3333333, something like that. Yes?
You actually can't put that in your calculator, the -2 over -4. It just says syntax error.
It won't let you do -2 divided by -4?
Probably divided by, but I just did the fraction and see if it would reduce it, but it would not. If you do divided by instead of like -2 over -4, it is
It says
0.5 on the
0.5.
calculator.
Correct, I get that. Here's the problem with that. What if it's this, or what if you get, then when you solve that, you're going to divide both sides by -16. Do you agree? And if you punch it into your calculator, it's going to tell you that it's whatever, 0.125. That's okay. But what if you solve one and you get -2 equal -6x? When you do this and you punch it into your calculator, it's going to tell you x is equal to 0.3333, and it's just going to keep saying threes until you get to the end of your screen. Is that the exact answer? Is this the exact value that x is equal to? No, because you know what this number really is? It's not 0.33333. It's 0.3333333333333. I don't have enough ink, breath, or time to keep doing this, but it just goes forever. So you can't write the exact answer, right? And sometimes when you do that, you get something like this, 0.1289763. God, what number have I not used yet? 4, 5, 1, 1, 2, whatever. And you run out of room and that's the answer you see. But that's not an exact answer. That's an approximation. And what we want in math is not an approximation. It's an exact answer. So 0.5 is exactly equal to 1/2. So I would accept that as the answer. But I would hate it because I know that sooner or later you're going to get a fraction and you're going to punch it in and you're going to get this and you're going to think that's your answer, when really the digits after that decimal point keep going forever, so you don't really know what the answer is. Everybody, when they get here, ought to be able to say that 2 goes into 2 one time and 2 goes into 6 3 times, right? And so you ought to be able to tell me, like in this case, the answer is 1/3, or this case, the answer is 1/2, right? Okay. This one is a rational equation, right? We got variables in some of those denominators. To do this problem, the one on the test is super similar to this. Like we could have made this, I could have made one like this that's super complicated, but I didn't. The one on the test is very similar to this one. To be able to do this, you really, really need to know how to factor this last denominator, the one that says 3x minus 9 on the bottom. The reason for that is because remember, just like that problem we just did, we got to figure out what the LCD is down here so that we can multiply both sides times that. We need to be able to see that 3x minus 9 has a common factor of 3. 3 is a factor of each term, right? If you have a common factor, you can factor it out front. Then you have to figure out what's your other factor. So what is the other factor? If I factor a 3 out of this, what's this other factor? X minus 3, do y'all agree? All we're doing again is distributing backwards. You just have to ask yourself, what would I multiply 3 times to get 3x? Well, 3 times x is 3x. What would I have to multiply 3 times to get this -9? Well, -3. Y'all see that? The reason I want to write it this way is because I want to realize that this literally is the LCD. Do y'all see that? If you can't figure out that 3x minus 9 is the same as 3 times in parentheses x minus 3, I'm afraid that what you might do is think that your LCD looks like this. You got x minus 3. Okay, you have to have a factor of x minus 3 in your LCD. 3, you got to have a factor of 3 in your LCD. And then you look at this and go, well, that's not 3 and it's not x minus 3. So I guess I also need a 3x minus 9 in my LCD. And you think that that's your LCD. But it's not, because really you don't need this. That's already covered because that literally is 3 times x minus 3. Y'all see that? And so that is the LCD. You got to have a factor of 3. You got to have a factor of x minus 3. You don't get anything new here that you don't already have covered.
Would you always find your LCD with the denominator that has the biggest, I guess?
Not necessarily. I told y'all I'm being nice on this test. Like if this, let's say this denominator had been 2x minus 1. Well, that doesn't have anything in common with these denominators, right? I can't factor 2x minus 1. In that case, my LCD would be 3 times x minus 3 times 2x minus 1. But I think the one you're going to see on the test is going to be similar to this. I know because I made up the test, right? So we got to multiply both sides times that LCD, just like we did in the last problem. And just like in the last problem, I'm going to do the right side first because that looks quick and easy. Does everybody see that the 3 on top and bottom cancel? And the factor of x minus 3 on top and bottom also cancel. And of course, that just leaves me with 1 times 2, which is literally just 2. Everybody with me there? Common factors on top and bottom can be canceled. Well, everything on top is also common on bottom. Do y'all see that? I'll cancel everything. Remember, if you cancel everything, there's still a 1 there, but that's just all that's left is 1 times 2, which is 2. Everybody with me? We're good? Okay, left side. Just like in the last problem, I've got to distribute. And do y'all see that when I multiply, y'all look where I'm pointing. When I multiply this LCD times this first term, do y'all see that the x minus 3 on top and bottom are going to cancel, right? But this 3 is not, right? Because there's not a factor of 3 on bottom in this one. There's only an x minus 3. So I can cancel this x minus 3 on top and this x minus 3 on bottom. That just leaves me with 3 on top and 3 on top here. 3 times 3 is 9. Everybody with? But now I have to multiply all of this LCD times this second term on the left side. And do y'all see that that time the 3 on top and bottom are going to cancel, right? I got a factor of 3 on top and on bottom, but I can't cancel this x minus 3 because there's not an x minus 3 on bottom over here. Y'all see that? So I just have to multiply x minus 3 times negative 1. In other words, I'm just going to say negative 1 times x is negative x. And negative 1 times negative 3 is what? Positive 3. Everybody with me? Now we just need to solve this. First of all, 9 plus 3 is 12, right? I should go ahead and combine like terms. So I get negative x plus 12, or 12 minus x is the same thing, equals 2. Well, hey, we're getting pretty close to done. Remember, I'm trying to get x by itself, so do y'all agree I ought to subtract 12 on both sides? So subtract 12 on each side. When I do, be careful. I don't have x by itself. I've got negative x equals 2 minus 12 is negative 10. So does everybody see that if negative x is equal to negative 10, then x must be equal to positive 10? That's true, and it's probably obvious, but if it's not obvious, just think of it this way. Negative x is the same thing as negative 1 times x, right? Well, you don't want negative x, you want positive x, but if you, anytime you have a number multiplied times x and you want to get rid of that number, you just divide both sides by that number, right? Everybody see? And so you could think of it like negative x equal negative 10 is the same as negative 1x equals negative 10. And if you divide both sides by negative 1, you literally get x equal 10, because negative 10 divided by negative 1 is positive 10. Everybody see that?
Paris has a
But
question.
again,
You can finish your statement if you need to.
what was that?
You can finish your statement if you need to.
Are you done talking? She said if you're done talking, she'll have.
Yeah, what's the question?
Okay, sorry, I thought I interrupted you. Okay, back up at the top before you simplified it, like with all of the lines, the second part. So
Yeah.
down a little bit. Yes. Okay, so when you're doing the left side, sorry, the x minus 3 cancels out because of the x minus 3 that you multiplied it with, and then the 3 on the negative 1/3 cancels out from the other 3 on the outside of it,
Yes.
right?
Let's real quickly, let's take a look at that, just so you could see what I'm doing. I'm kind of counting on y'all to figure out the distributing, but let me show you what's really happening sort of in full-blown mode. So there's that left side, right? Exactly what we're doing on the left. What I'm doing is I am distributing this LCD. So I'm doing 3 times x minus 3 over 1 times this first term, 3 over x minus 3. And then I'm doing minus 3 times x minus 3 over 1 times 1/3. And so, because I'm doing this times this, that's what I've written here, right? And then I'm doing this times this, which is what I've written here. When you do it, do you see that here those cancel, but you're left with 3 times 3, which is 9. Then here, when I do that, the 3's cancel, but the x minus 3 doesn't, and that's going to be 1, it's really negative 1 times x minus 3, which is negative x plus 3. Does that make sense? Maybe not.
Okay, you're just going really fast. So can you, okay, so I
Okay,
get
okay, hang on.
I get the 9. So on the x minus 3, okay. So initially you just crossed out the 3 on the outside because the 3 on the bottom also cancels because they're opposite, correct?
Because, yes, because think about if I was doing this, because this is what I'm doing. Let me see if I can move up where you can see. That's what I'm doing, right? Because if you look back up here, so look here, but now look back up here. I did 3 times x minus 3 times this first thing. That's where that 9 came from, because the x
Right.
minus 3 is canceled. Then I have to do 3 times x minus 3 times this second thing, okay?
Right.
3 times x minus 3 times that.
But
Do
the
you see
simple
I
way
can't-
in the beginning to cancel is cross out the 2 3s and then just do x minus 3 times negative 1.
That's it. And that's
Okay,
where
I just wanted
negative
to clarify your crossing out at the top. That was it.
positive
Okay,
3
perfect.
come from. Does that make sense?
Okay.
Yeah, we're just canceling whatever factor is common on top with what's on bottom. That's what we're canceling. Everything else we have, that's anything that's left here, we have to multiply times what's on top. Does that make sense?
Yeah.
Okay.
Yes, I didn't necessarily, yeah. I'm just asking I'm not saying that you had to work it all out. I was just clarifying that the
No, I
crossing
want to
out
make sure
was
I want to make sure that everybody sees it, because
for
this is
sure.
one of those problems that students always think, oh, that's going to be the hard problem on the test. It's not. If you just see what's going on and how you're multiplying every term times that LCD, I think that problem's doable. Okay,
Thank you.
how about complex numbers? Here we're just asked to subtract these. Somebody just tell me what we get when we do that. Let's see if we got that figured out yet. What's going to be your answer when you subtract these complex numbers? 8i, is that what you said? So somebody votes for 8i, so let's take a look. Remember, all we're doing is combining like parts, right? So the real parts, we're going to do 2 minus 2. Well, 2 minus 2 is definitely 0. Do y'all agree? And then we're going to do, be careful, we're not going to do 5i minus 3i, right? Because this is, y'all look where I'm pointing, this is 5i minus negative 3i. Isn't negative, y'all look where I'm pointing, isn't negative times negative positive? So really I'm doing 5i plus 3i, which is positive 8i, and I agree that 0 plus 8i, the simplest way to write it would just be to say that that is 8i. If you wrote 0 plus 8i, I wouldn't take off. Technically, that's standard form. But, you know, if the real part's 0, you could just write 8i. Everybody with me? Is everybody good there? We're just combining like parts. Problem 6, we are supposed to multiply these two complex numbers. So what's kind of the model for that? What are we actually going to do? FOIL, right? So when we FOIL, 3 times 2 is 6. 3 times negative 3i is negative 9i. Everybody good there? And then we're going to do the inside part of FOIL. 2i times 2 is positive 4i. And then we have to do last times last. I'm going to write everything out longhand. Probably a good idea to do this on the test. You don't want to make a mistake. When I do 2i times negative 3i, positive 2 times negative 3 is negative 6. But don't forget, because this is important, you also have I times I. Y'all see that? And I times I is I squared. Now, here's where we got to think about what we're doing. What is I squared equal to? -1, thank you. Thank you for keeping me from bashing my own brain in. I squared is -1. I feel like we've said a couple of times in this course that I is a symbol we use to represent the square root of -1, which of course means that I squared is -1, right? So, okay, I've got 6 minus 9i plus 4i minus 6 times -1. Do y'all agree? Because I squared is equal to -1. So that's really -6 times -1. And do y'all agree that that is really +6? -6 times -1 is +6. Everybody see? So now we're just combining like parts. 6 plus 6 is 12. -9i plus 4i is -5i. So we get 12 minus 5i. Everybody good there?
Hold on one second. I need to take a picture of that because I'm trying to like watch
Okay.
and write at
See
the
it
same
all
time.
there.
Yes, I have a picture of it. So really quick to backtrack a little bit on 5. Can you,
Yeah.
I have that on my, like when I was practicing, but can you just refresh my memory why 2 plus 5i is 0?
2 plus 5i is not 0. You can't add 2 and 5i. They're not like terms. Think of it that way. This is like
Oh, so
combining
you have to
like
just
terms.
combining like terms.
Yeah, here's what you're really doing. When you're adding or
Oh, I
subtracting,
see.
when you're adding or subtracting, the model is combining like terms. When you're multiplying, it's FOIL. Think of it this way. What this really is, maybe this will help, especially if y'all mess up the signs here, where the negative of -8i, 3i is really
The parentheses,
positive
but-
3i. Do it like this. You got 2 plus 5i. The negative of 2 is -2. The negative of -3i is +3i. And then just combine the like parts. Just like we did down here when we said 6 plus 6 is 12. Well, here we're saying 2 minus 2 is 0, right? And when we did -9i plus 4i here to get minus 5i, well, here we're doing 5i plus 3i to get +8i. Does that make sense?
So, yeah, so technically you could remove the parentheses. I
Yes, you
think.
could. And if you're
Okay.
that student that tends to make sign errors where you have these minuses like this, it's probably not a terrible idea to just take a step and rewrite it where you go ahead and take care of that negative by reversing those signs, right?
Can I see the answer?
Hmm?
Can I see the answer?
Thank you.
Okay. Okay, we good? Shall we plow ever onward? Division. Dividing complex numbers. The trick is what you're looking at is what's on bottom here, the thing that you're dividing by, in this case 2 plus 3i. I want to multiply that denominator, 2 plus 3i times something. What do I want to multiply it times? 2 minus 3i. So what we want to do is whatever this complex number on bottom is, we want to multiply it times its complex conjugate. Remember what the complex conjugate is. It's this exact same complex number, except we reverse the sign of the imaginary part, of the I part. So instead of 2 plus 3i, the complex conjugate of that is 2 minus 3i. Everybody see that? And we should all know at this point, if you think about this like a fraction, I mean, it acts like a fraction. If you multiply the bottom times a number, and we're multiplying the bottom times the number 2 minus 3i, you have to multiply the top times that same number, 2 minus 3i. Everybody with me? And that's really the sort of the brunt of what we've got to get done here. Once we multiply the tops and the bottoms times 2 minus 3i, from there it's just simplifying our answer. So when we do this, the denominator's the easy one if you remember the shortcut. Y'all remember, when you multiply two complex numbers, all you do is square the first number, 2 squared. You square the second number, 3 squared. Everybody say what I mean by first and second number? The real part, you square the real part. 3 is the imaginary part. You square that. And this is the important, you put a plus between them, not a minus, a plus. Square the first number, square the second number, put a plus between them. That's 4 plus 9. Do y'all see that? Which is, of course, 13. And that is our denominator. Now, you could FOIL it. If you want to FOIL 2 plus 3i times 2 minus 3i and FOIL it out. If you do that and combine the like parts correctly, just like with that last multiplication problem we did, you'll get 13. But if these numbers are complex conjugates, and they are, that's why I chose 2 minus 3i, is because it's the complex conjugate of 2 plus 3i. This always happens. Square the first number, 2 squared is 4. Square the second number, 3 squared is 9. Add them together, you get 13. That's the denominator. Now on top, you do have to FOIL, right? Because those are not complex conjugates. So when we do that, we do 2 times 2.
On the bottom,
Yes.
do you always keep it positive? Or I guess
It's
if you
always
would FOIL it.
positive. It's always positive because all you're doing
Okay.
is squaring 2 numbers and adding them together. And when you square 2 numbers, it doesn't matter if they're positive or negative. When you square them, they're positive. Isn't that right? That
Okay.
makes sense? So
Yes.
if this had been negative 2 plus 3i, you'd have said negative 2 squared plus 3 squared, but negative 2 squared is still positive 4, right? You still have 4 plus 9, which is positive 13. Does that make sense?
Yes.
Okay. So on top, we're FOILing. 2 times 2 is 4. Then we got to do the outside part. 2 times negative 3i, that's negative 6i. Then we have to do the inside parts. 2i times 2, that's positive 4i. Then we got to do last times last. Now, last times last, that's going to be negative 6i squared. That just coincidentally turned out to be what happened last time, too. We got the same thing. But the important thing to see is that I squared is negative 1. And negative 6 times negative 1, y'all look, because I'm about to mark through some of this and change it. I squared is negative 1. And does everybody agree that negative 6 times negative 1 is just positive 6? Then that negative 6i squared is really just positive 6. So now we just combine like parts. 4 plus 6 is 10. The imaginary parts, negative 6i plus 4i is negative 2i. That's all over 13. Remember, that's kind of our big goal. Remember we said when we're dividing complex numbers, like 2 plus 2i over 2 plus 3i, our goal is to get this thing written so there are no i's in the denominator, and we've done that. The only other thing to do is you generally should write this answer in standard form for a complex number, which just means you split this up into its real part, 10 over 13, and its imaginary part, which is going to be minus 2 over 13 I.
So is that how you want it done?
It is, because this is standard form for a complex number. Now, with that question, I think maybe what you might also be asking sort of implicitly with that question is, what if you gave me that as your final answer? If you gave me this as your final answer, I would not take off points, but I would probably write a little red phrase there, I'd probably put standard form question mark or something like that. I would not take off points. This is not an incorrect answer. But generally, particularly when we're working specifically with complex numbers, we like to write it in standard form, right? But y'all will probably see that I'm reasonably merciful as a grader, so I wouldn't take off points if you gave me that as your final answer, right? Okay. Problem 8, the square root of negative 81 plus the square root of negative 16. There is a problem very similar to this on the test, and I cannot tell you how often I see students miss this problem. This arguably is the easiest problem on the test, or the problem like this. We're asked to simplify this expression. What is the square root of negative 81?
Plus or minus square root of 9. No, plus or minus 9.
First of all, it's not plus or minus because I don't have a plus or minus outside the square root. If there's no sign, that means there's just a positive sign. Do you agree with that?
Oh, yes. Okay.
Okay. And the square root of negative 81, Shay, what did you say it was?
Oh, so 9i.
9i. Everybody agree with that? The square root of 81 is 9. So the square root of negative 81 is 9i. I've got a plus sign. That plus sign is not under the radicals, it's outside them. Nothing's happening to change that. What is the square root of negative 16? 4i. I agree. Am I done with this problem? Have I now simplified it?
No.
Combine like
So what
terms.
should my final answer be? 13i? So I say that to say this. I always have a student or two who on a problem like this, they'll give me that as their final answer. Like I would hope if we make it to 9i plus 4i, we can see that that is 13i. Everybody see that? So really what it comes down to is you got to know that when you take the square root of a negative number, you get the square root of that number times I, right? And if you're adding them, then you're just adding them. You're adding the 9 and the 4 and keeping the I, right? Combining like terms, basically. Okay, problem 9. We're moving on to 1.5. We're just asked to solve this equation. We're not told what method to use. If I didn't tell you a method, that means there's some way to solve it that doesn't require you to use the quadratic formula. But if you used the quadratic formula on this problem and found the correct solutions, I would not take off points. But my advice is this is easy to factor. It's a lot easier and faster to factor it than it is to use the quadratic formula, use it correctly, and not screw up the arithmetic. What are the two numbers that go here?
-3, -4.
Say again.
-3, -5.
I agree with one of those numbers. -3 and +5. I agree. First of all, do y'all see that these two numbers are going to have opposite signs? Because they multiply to be -15. See, if you're not looking at that before you look at anything else, you're not going to get it factored. If you're not looking at that last number going, okay, they multiply to be, I think what a lot of students do is they look and they go, oh, they multiply to be 15. No, they don't. They multiply to be -15, and that's important because that tells you one of the numbers is positive and the other's negative, right? Those numbers that have opposite signs have to add to be positive too. So the bigger number has to be positive. And of course, you're going to really subtract to get 2. So it must be +5 and -3. So does everybody agree that the solutions are, notice, -5 and +3? Y'all see that? Okay. Problem 10.
So we just flip the signs. Once we
Yeah, you do, but what's important, because otherwise you're going to start flipping signs every time you see a sign. Why are we flipping the signs? She's saying, look, this was +5 and I wrote -5 for the solution. And this was -3 and I wrote +3 for the solution. Why did I do that?
because it gets you to 0.
Because, right, because what do I add 5 to 5? What do I add 5 to get 0? Well, -5, right? I wouldn't put +5 here because 5 plus 5 isn't 0, it's 10. Y'all see that? But yes, you are flipping the sign. But that's because that's the number that you're going to replace x with to make that factor 0. Y'all see that? Okay, does everybody see on number 10, the first thing I need to do is subtract 3 on each side because I want to set it equal to 0. So I get 2x squared minus 5x minus 3 equals 0. And I want to factor this. And you could use that factoring method. I'm not going through all that because we don't have time to do it, and we've done our factoring. If you got absolutely stuck and you just could not factor this no matter what you tried, what would you do instead? You would use the quadratic formula, and you would do your arithmetic carefully and simplify it carefully. Really and truly, if you know what you're doing, you probably don't need the factoring method here, because do you agree that the only possible way I could start is 2x times x? That there's not more than one option for two things that multiply to be 2x squared.
Why is 2 not on the outside of the parentheses?
Why is what?
Why is the 2 not on the outside of the parentheses?
Well, 2's not a common factor here. I can't factor out a 2, can I?
Okay, so the 2 goes
What
out.
goes first here times what goes first here has to equal 2x squared. Do you agree? If I put a 2 outside the parentheses, y'all look, I would have to factor a 2 out of every one of these terms, which technically I could, but that would leave me with my other factor being x squared minus 5 over 2x minus 3 over 2. You do not want that, right?
Okay.
I know if these are going to factor, I've got to start with 2x times x. I also know that the last two numbers have to have opposite signs. Why do I know that? Because they multiply to be -3. Then I also know that the true numbers are 1 and 3, right? There's only a few things I can try. Y'all look where I'm pointing here and listen real carefully because I don't have time to write every single possibility down. I could try +3 minus 1. I could try -3 plus 1. I could try +1 minus 3, or I could try -1 plus 3. That's the only stuff I could possibly try. And it should not take much to figure out that that is what's going to work. Why? Because I know that these numbers have to multiply to be -3, which means my options for these two numbers are limited. And I also know, y'all look, when I do the outside part of FOIL and the inside part of FOIL and combine those, I have to get -5x. Well, that gives me -6x plus 1x, which is definitely -5x. But again, we don't have time to reteach how to factor because we're doing a test review and we're out of time if we're not careful. If you get absolutely stuck and cannot factor this, use the quadratic formula, but use it carefully. Don't just throw some numbers up there and like frantically do the arithmetic without paying attention to what you're doing. At any rate, we've got it factored. What are the solutions? I agree with +3, but I don't think I agree with the other one. +3 is the solution that goes with the second factor. What goes with the first factor? Why are y'all not learning the stuff that we've talked about already in this class? Yeah, we talked at some length about how to find the solution that goes with this factor. Reverse the sign of the constant term, put it over the coefficient of the x term. Instead of +1, we need -1. We put it over 2, -1/2. I also talked about when we did have that talk, that look, what you're really doing is you're figuring out, y'all look at the factor, 2x plus 1. That factor, 2x plus 1, what I'm trying to figure out is what I replace x with to make that equal to 0. And if you had to, you could just solve that equation to find out what you would replace x with. When you subtract 1 on each side and get 2x equal -1, and when you then divide each side by 2 and get x equal -1/2.
Where do you get the negative?
Well, if it was positive, how could I add a positive number plus 1 and get 0? Because I subtract 1 on each side, and now it becomes 2x equals 0 minus 1 is negative 1. And wouldn't I then divide each side by 2? And isn't that negative 1/2? See what I'm saying? Okay.
I have a
Problem
question.
one.
And
Yes.
can you just leave that up there really quick so I can take a picture? Okay, I got that. So the 3 is because the x minus 3 is just straight up positive 3, right? And then the
Well,
2x.
3 because positive 3 is what you replace here to get positive 3 minus 3 is 0.
Right, and then the negative 1/2 is over on the other side because you have to divide by that too.
Yes, and you
Like
can
it ha-
see this
It has
works.
to be x only.
If I multiply 2 times, if I replace this x with negative 1/2, and I do 2 times negative 1/2, can you see, like in your mind, like even if you don't write it down on paper, if I do 2
Yes.
times negative 1/2, 2 over 1
Yeah.
times negative 1 over 2, the 2's cancel, it just leaves me with 1 times negative 1, and that's negative 1 plus 1 is 0, right? Everybody with me?
And I understand the arithmetic. I was literally just asking, it's because we can't leave the 2 in front of the x is why we have to get the x by itself.
Right, right,
Okay.
yeah. You could, in fact,
all I needed to know.
is that Olivia? I don't know if that's Olivia or Ashley. Is that
Yes,
Olivia
that's
asking the
me.
question?
Yeah,
I think
yeah.
you saying that, you could do this. You could say, okay, I know that what I need to add 1 to get 0 is negative 1. So I need to figure out what should x be so that 2x is negative 1. Like that's literally what we get here. If we say I need 2x plus 1 equal to 0, it's I need to figure out what x needs to be so 2x is negative 1, right? I mean, if you wanted to think about it that way, you could. But I'm telling y'all, the fastest way to,
That's not even where I was going with that. I was literally just asking, it's because we
Yeah.
can't leave the 2x alone. We have to make it x, that's it. Like only x
yeah, you have to
equals
figure out what to
blank.
replace x with,
Okay.
so that when you multiply 2
Okay, I
times
think-
and then
I
add
think
1,
I-
you get 0. But I'm
I
just
think
telling
we're like
y'all.
totally different thought processes. That's not
But
what I'm
I'm just
talking
telling
about.
y'all.
I think,
I'm just
okay.
telling y'all, in terms of survival skills on a test, if you reverse the sign of that constant term and put it over the coefficient of the x term, that's going to be the solution that goes with that factor every single time.
Reverse the sign and put it over
Reverse the sign of the constant term in that factor. This is plus 1, make it minus 1. Put it over the coefficient of the x term too. That's negative 1/2. The same thing works here. We just don't have to think it through that far. Y'all look where I'm pointing. Reverse the sign of the constant term, right? Instead of negative 3, make it positive 3. Put it over the coefficient of the x term. That's 1. 3 over 1 is 3. That's all you're ever doing, right? Okay, we've got to move on. We're running out of time. Problems 11 and 12 both specifically tell you to use the quadratic formula. That's not because I wouldn't. Oh, I must have skipped a problem. Did I skip one?
We're on number 11.
I skipped 11. What did I do with it? I probably forgot to write it out.
It's right there on top.
Oh, it's on top. Okay. Yeah. It's 12 and 13. Okay. Problem 11. I don't know how to factor that, but I do know that I could add 98 to each side, which gives me x squared by itself equals 0 plus 98 is 98. And what do I do now? Take the square roots of both sides. Now here, we want both square roots because both of them will make the equation true. So I'll get x equal plus or minus. Okay, square root of 98. I don't know that square root. It's not a perfect square, but I should be able to figure that there is a perfect square factor in 98. 98 is 49 times 2, right? So the square root of 98 is the square root of 49 times the square root of 2. And I know what the square root of 49 is. It's 7. So the square root of 98, if I simplify it, is 7 times the square root of 2. And again, remember, we need the plus or minus because 7 times the square root of 2 is a solution to this equation, and negative 7 times the square root of 2 is a solution to that equation. Everybody with me? The quadratic formula. That's it. We got to learn it, take it, keep it, remember it in our brain. What if, when y'all take the test next week, what if I wrote out the quadratic formula and put it on the document camera throughout the test? Would that help?
Oh, yeah, factually, yes.
I will do that. See, y'all never pay attention to what I'm saying. That's what I'm driving at y'all about.
Previous question. Well, no, I was trying to understand I was trying to understand how you got
Writing
7.
down the remainder of
Do
the
you agree that 98 is 49 times 2,
Correct.
right? And so the square root of 98 is the square root of 49 times the square root of 2.
So why do you not square root of the 2?
I don't know the square root of 2. Do you?
Wouldn't it be just 2?
So 2 squared is 2. The square root of 2 is whatever number you multiply times itself to get 2.
Okay, so there's nothing that you can do.
Yeah, the square root of 2, if you put it in your calculator, is 1.414 ... Numbers keep going forever. It's irrational. But we do know the square root of 49. It's 7, right? That's what I did. Okay, y'all. So I'll give y'all this formula on the test. I'll put it on the document camera and leave it up through the test. With that said, we got to hurry because we're about out of time. Do y'all agree x squared is the same as 1x squared? So here we go. Our a is 1. Our b is 2. That's the coefficient of the x term. Our c is the constant term. That's -9. And so we're just plugging those into the quadratic formula. X equals -b. That's going to be -2. Plus or minus the square root of b squared. That's going to be 2 squared. Minus 4 times a, which is 1, times c, which, be careful, it's not 9, it's -9, right? And that's all over 2 times a, which of course is just 2 times 1. Everything else is simplifying. So we got -2 plus or minus the square root of 2 squared is 4. Now be careful here. I've got -4 times 1 times -9. -4 times 1 times -9, that is positive 36. -4 times positive 1 is just -4, which you then multiply times -9. -4 times -9 is positive 36. That is all over 2 times 1, which is 2. Everybody with me here? Everything else is simplifying. So we've got -2 plus or minus the square root of 4 plus 36 is 40, right? So the square root of 40 all over 2. Now, what we need to do now is see if we can simplify this square root of 40. So this is real similar to what we did with that square root of 49. There's several pairs of numbers I can multiply to get 40, but there's only one pair of numbers I can multiply to get 40 where one of those numbers is a perfect square, and that would be 4 times 10. Do y'all agree? So the square root of 40 is the same thing as the square root of 4 times the square root of 10. I know what the square root of 4 is. It's 2. I don't know what the square root of 10 is. It's irrational. So the square root of 40, if I simplify it, is 2 times the square root of 10. So I have -2 plus or minus the square root of 40, which we just figured out is 2 times the square root of 10, all over 2. Now I'm almost done, but do y'all see that because 2 is a factor of every term on top and bottom, we can cancel a factor of 2 in each term? Everybody see that? If you're canceling anything off the bottom here, you can only do it if it's a factor of not just one of the terms on top, but every term. But 2 is a factor of every term, so we can cancel a 2 from every term, and we should to simplify. 2 goes into 2 one time, 2 goes into 2 one time, 2 goes into 2 one time. If you look at what I've got here, I've got -1 plus or minus 1 times the square root of 10 is just the square root of 10. And of course, that's all over 1, which is just -1 plus or minus the square root of 10. Everybody good there? We're good? We got to move on because I'm telling you we're out of time. So moving on. 13. A is 2, B is 6, C is 5. The quadratic formula says, where did I write that at? Oh, over here. The quadratic formula says x equals negative b. Well, that's negative 6. Plus or minus the square root of b squared, that's 6 squared. Minus 4 times a times c. Minus 4 times a, which is 2, times c, which is 5. And that's all over 2 times a, which is 2 times 2. Now we simplify. So I've got negative 6 plus or minus the square root of 6, the square root of 6 squared is 36. Now notice here, this is negative 4 times positive 2 times positive 5. Do y'all agree? When I multiply those, it is going to be negative, right? Negative 4 times 2 is negative 8. Negative 8 times positive 5 is negative 40. And that is all over 2 times 2, which is 4. Under that square root, 36 minus 40 is negative 4. So I've got negative 6 plus or minus the square root of negative 4 all over 4. What is the square root of negative 4? Say again? 2i, right? The square root of 4 is 2. So the square root of negative 4 is 2i. And that's all over 4. Can I simplify that at all? Do y'all agree that I should be able to cancel a 2 from every term? Every term has a factor of 2, right? 2 goes into 4 2 times. 2 goes into 6 3 times. 2 goes into 2 1 time. I've got negative 3 plus or minus 1i. I could literally write 1i if I want to, but 1i is just I, right? It's all over 2. By the way, you could write that in standard form, but typically, if you get complex numbers that are solutions to a quadratic equation, we typically just leave them like this. That's perfectly fine.
Do you mind showing the full page, please?
Yes, sorry.
Thank you.
All right. Moving on, problem 14. Oh, this is like what we're doing tonight, right? So x to the 4th minus 10x squared plus 9. This is similar to a problem we actually did, I think, right? Not exactly the same, but it's similar. So we're going to make a substitution. Remember, x to the 4th is the same thing as x to the 2nd squared. So if I replace x to the 4th with x to the 2nd squared, which is the same thing as x to the 4th, it looks like this. And so I'm going to let u equal x squared, and I'm going to replace these x squareds right here with u. So that's going to give me u squared minus 10u plus 9 equals 0, and I need to factor and solve that equation first.
So we only use the u when we have an exponent greater than 2?
I don't like the way that question sounds. When you have an exponent of 4 and an exponent of 2, you could do that. Let's say that. Technically, it turns out that as long as this exponent's twice as big as this one, there's a way to use a substitution. I didn't take the time to look at a lot of other weird cases, but there are a lot of weird cases where this idea would work. But I promise you the one you're going to see is like this one. And do y'all agree that that needs to be u minus 1 and u minus 9? Negative 1 times negative 9 is positive 9. Negative 1 plus negative 9 is negative 10. So that's right. And I get u equals 1 and u equals 9 as the solutions. But remember, u is really x squared, right? So where that says u equals 1, that's really x squared equals 1. And where this says u equals 9, that really is saying x squared equal 9. And we're just going to take the square roots of both sides on each of those. And remember, these numbers have both a positive and negative square root, and we're going to need both all those because they're all solutions. So the square root of x squared is x, equals plus or minus the square root of 1 is 1, and x equals plus or minus the square root of 9, which is plus or minus 3, and there's our 4 solutions. Everybody good there? Problem 15, does everybody agree that I need to square both sides? Square both sides. On the left-hand side, super easy. When you square a square root, they just cancel, you just get x plus 14. On the other side, you've got to actually FOIL. You've got to multiply x minus 6 times itself. So x minus 6 times x minus 6. Wow, this looks like, did we do this exact problem? Did one similar. We get x squared minus 12x plus 36 when we FOIL this and combine like terms. And then I need to subtract x on each side. And I need to subtract 14 on each side. Because I need to set it equal to 0, right? So here on the x squared side, I get x squared minus 13x, because that's minus 12x minus 1x, right? And 36 minus 14 is positive 22. And of course, on the other side, everything cancels and I get 0. I need to factor this and solve it. What are the numbers that go here? Y'all too slow. Does everybody agree that negative 2 times negative 11 is positive 22? And negative 2 plus negative 11 is negative 13. So what are the two solutions to this quadratic equation? 2 and 11, I agree. Now, this is one where we got to remember, the question is, are these both solutions to our original equation? The original equation was the square root of x plus 14 equals x minus 6. Now, I know I got y'all kind of confused when I did these checks on the run a while ago, but we've got to be on the run. We're out of time. When I plug 2 into this original equation, this value of x, 2, into this original equation in place of x, do I get a true statement or do I not?
No.
No, because 2 plus 14 is 16, and does everybody agree the square root of 16 is 4? But I also have to plug 2 in on the right side in place of x, and 2 minus 6 is negative 4. That statement is false, so 2 is not a solution to the equation. What if I plug 11 in? Do I get a true statement? 11 plus 14 is 25. Does everybody agree that the square root of 25 is 5? But remember, I also got to plug 11 in place of x on the other side. Isn't 11 minus 6 also equal to 5? That is a true statement. So 11 must be the only solution to that equation, right? So make sure when you solve the problem like this on the test, if you solve it correctly, you're going to probably find 2 solutions. But don't tell me that both of those are solutions, because you're claiming, if you do that, you're claiming 2 solves this equation. It doesn't. Even though I wouldn't want to take any points off, I would kind of have to take off something because you told me something was a solution that actually was not. Y'all see what I'm saying? Okay, so check your answers there. Finally, last 2. Let's zip through these things. Problem 16, absolute value equations. Does everybody agree I need to subtract 3 on each side first? Remember, we're supposed to get the absolute value by itself first. So when I do, I have the absolute value of 3x minus 5 equals 13 minus 3 is 10. Okay, now that is absolute value equal positive number. So do y'all agree this is the point where I set up 2 equations and solve? 3x minus 5 equal negative 10. Is this the same problem that was on the, that we did tonight? Or 3x minus 5 equals positive 10, and we're going to solve each of those. And here we're going to get x equal negative 5/3. I'm zipping through this because I actually didn't realize it, but this is the same we did this exact problem. And here we add 5 on each side, we get 3x equal 15, so x equal 5. And those are our solutions. What about 17?
It's no solution.
Of course, because an absolute value can't be equal to a negative number.
Is that
We've
how you
got
would
to
write
do
the
this in-
answer? Is just the 0 with the
I'm
cross
sorry?
through it? Is that how you would write the answer?
Yeah, okay, that's a good question. The little circle with the slash through it, that's the actual sort of math symbol. That means no solution. Technically, it means the empty set, the set that has nothing in it. The solution set is empty. It's the same as saying no solution. But if you literally wrote no solution, I would accept that also. Just make sure, you know, that you do something to let me know that this doesn't have a solution. In other words, if you just left it blank, I would think, okay, they didn't attempt the problem or they didn't know how to do it. You know, make sure that you let me know that you knew there was no solution, whether you use the sort of math symbol or if you just write it out. See what I'm saying? Is that okay?
Yes,
Whew.
sir.